Claudia, I'll introduce Masaki Fujimoto. He is the Deputy Director General for the ISAS organization within JAXA. And so, oh, he's showing us a very cool video. Masaki, please go ahead and thank you for being here so late in Japan.
Well, my pleasure, thank you. So including the subsurface material that was excavated by this impact experiment and sampled during this second touchdown, HAPS-2 has brought the samples back from Ryugu, and the landing spot was in Australia. So this is where the capsule landed, and we, the team, went all the way to this place so that we can recover the capsule under the COVID-19 pandemic. And it wasn't just the COVID-19, but it was also the weather. The weather, it was heavy rain until the noon the day before, and then the sky cleared up, but still gusty wind. And then every condition turned out to be rather favorable. And that's why we got this very nice movie of the fireball created by the capsule. If you were, and you would have watched this if you were standing in Cooper Pedy, 400 kilometers north of the landing site. So we spotted this fireball, and we got the beacon. We received the beacon signal from the capsule and managed to localize the landing spot. So we picked up the capsule, brought it back to Japan, and when we opened the capsule, we confirmed that it was a big catch. The total amount of samples from Ryugu was 5.4 grams, which is 50 times the minimal requirement. And the creation activity is going on rather smoothly. We've done the initial creation already, and now we are in the initial analysis phase. And starting next summer, the samples will be available for the international communities. And also the comparative sample analysis study with NASA OSIRIS-REx is really something we are looking forward to. Well, HAPS-2 has been really successful, and it's a really popular mission among the journalists. And one of the questions we quite often receive is, why don't you fly HAPS-3? And our answer is, of course, yes, we are preparing MMX Phobos sample return mission. And actually, we are really moving full steam towards the launch in 2024, and the sample will be returned in 2029. We are getting a big support from the government. So I think we are really getting, running towards the launch in 2024. In MMX, we will be landing on the surface of Phobos for like a few hours. And during that landing interval, we will operate our samplers. One is the core sampler, C sampler from JAXA, that will get the sample from subsurface. And the other sampler is coming from US. It's a pneumatic sampler, which collects the sample from the surface. So by having these two sampling mechanism with a different way of working, we'll make sure that we get some samples from Phobos for sure, because that's what we really care about. DLR and CNES has provided mascot for HAPS-2 mission. And now for MMX, CNES and DLR will be providing this nice rover so that we can have a nice reconnaissance mission first, and then we can select the landing site, the best landing site on Phobos, hopefully. So this MMX is really a full-scale international collaboration. So MMX, it's a round trip to Mars, and we'll be landing on and sampling from the surface of Phobos. That possibly includes samples from Mars, because impact event on ancient Mars could have brought samples to the surface of Phobos. So MMX has a flavor of Mars exploration as well. So now I talked about JAXA's, the first step of JAXA's Mars exploration. What about lunar exploration? Well, recently there has been some interesting move within our system. So that's something I want to share with you. In Japan, we realized that a variety of interesting future activities on the lunar surface. But then a question that was raised by one of the committee members was that, who will pave the path? A NASA solution would be CLIPS, as we have just heard from the previous presentation. But JAXA solution was a bit different. It wasn't our proposal, but JAXA was requested by a governmental level committee to set up a program that will produce top-class science results from activities on the lunar surface. And by doing so, we are asked to pave the path so that future activities will have a smoother way of moving forward. So this program that will go for the top-class science result will continue to 2030s. A precursor phase until 2030 is expected, and the main phase that will be developed in 2030s. We can assume of involving a pressurized manned rover that JAXA and Toyota are developing now. Well, it sounds like a good opportunity, but there are two sort of constraints, well, two expectations on us. It has to be a top-class science that we produce. Well, I think that's fair enough. And the program also has to pave the path so that a variety of those people who are interested in lunar activities will be able to participate in the fully fledged lunar surface activity beyond this program. So it's a heavy expectation, but on the other hand, it's giving us a nice opportunity for science. And besides, we have no choice. We have to say no anyway. So that's where we are now. And this is really a recent movement happening in this country. So then what are those big topics that will produce top-class science by having activities on the lunar surface? We have picked up 3 topics. First one is the low-frequency radio telescope on the far side, and that will probe into the dark age of the universe when the first star was not born yet. And the second theme is returning samples from the key impact craters so that we can date the early history of the solar system. And by doing so, we can learn how dynamically our solar system formed and what was the heavy late bombardment was like. And third theme is the lunar seismometer network. By having this network, we can learn about the internal structure of the moon and learn about the initial evolution phase of a rocky planet. So it's not clear yet whether we can really pursue all of these 3 themes. It could be just one of them, it could be 2 of them, it could be all of them. So everything is just ramping up now, and scientists are excited, but feeling the pressure at the same time. But I think, again, that's fair enough. And yeah, again, this isn't something we propose. This is really coming from above. And yeah, we have to live up to the expectation. So that's where we are now in terms of JAXA lunar exploration. That's all I have to say. Thank you.
Thank you very much. That's quite a comprehensive program that you guys have been working on and are expanding to. For your lunar science program that is very new, so maybe you don't have an answer to this, but I understand that the program will go for the next, say, 9 or 10 years, but do you have any idea how long it will take to stand up and start making opportunities available for your community?
Well, it's really starting now, but we have something I didn't touch on today is that we have a project by the name SLIM. That's a small-scale pinpoint landing project, and I think it's almost mandatory that we should think about how to utilize that technology we are gaining from the SLIM project. So the next 10 years will be like having small pinpoint lander on the surface. That will be the precursor to the full-scale exploration in 2030s. So eventually we will come up with the concrete pictures of what those precursor missions will be. And then I think there will be opportunities for international collaboration. And besides, if you look at these 3 themes, it's something that almost everybody will think about. And I'll be shocked if there is no international collaboration when we perform the full-scale mission in 2030s.
That's wonderful. Okay, so we're open to additional questions for Masaki. If anyone wants to raise their hand or put a question in the Q&A, we'll give it just 1 second. We have something from Mahesh Anand. It says, not quite a question, but a comment to just congratulate JAXA for such a bold approach. So
Well, again,
wonderful.
it's coming down from above for the lunar part. So yeah, we'll see if we can, make up to the expectation. Yeah, thank you for the encouragement.